Hello, everyone. My name's Colt, and I work at Sandstone Care. And that's enough about me. Today, we're going to learn the super secret, weird, freaky brain science of drugs. Right? So, for those of you that are actually interested in neuroscience or psychology, what you're going to see is that this is a cartoonish way of describing a really complex process. So for those of you that are not necessarily fascinated with neuroscience or psychology, what you're going to take away from this is knowledge of how drugs work inside of the brain in a very digestible way. In a way that after this video, you will be able to teach this. And you will be the ambassadors of this knowledge, right? So, one of the things that I love about the way that Sandstone presents this information is that this is a way that we can talk about drugs that doesn't have to include judgment. And it doesn't have to include imposing one's morality on another. And it gives us all this common language that we can use when talking about drugs. So, if we're going to talk about how drugs work inside of the human brain, I'm going to do a brief recap of some things that you may already know about the human brain. So if you took a lightsaber and you sawed through my head, right through my forehead, my nose, and my mouth, and took the two pieces of my head and pulled them apart, what you would see is a big, beautiful brain, and an eyeball, and a nose, and a smile, and my vampire fangs. Then, inside of my brain, you would see all of these super tiny little brain cells, right? These little brain cells that are called, neurons, right? Does anybody know how many of these I might have? If we were to count all of the neurons inside of my brain, we could count to 100 billion. 100 billion. That is a huge and ridiculous and astronomical kind of number. And it's hard for me to wrap my mind around the idea of 100 billion of anything living inside of a skull. But the thing about it is that each one of these 100 billion, each one of these, has a chance to talk to dozens or hundreds or thousands of other brain cells. And each time that they talk to each other, they make these little connections or pathways, if you will. So these 100 billion are creating 1 quadrillion of these connections. I thought 100 billion was a big number. That's ludicrous, right? But the thing about it is that each one, when they talk to each other, we're going to zoom in on this space right here, where they are talking to each other, where this connection happens. And when we zoom in on these brain cells, what we see is that the brain cell looks kind of like an octopus, right? It has these bodies with these super mega crazy long legs that branch off of these bodies. And these legs are so long that if you took my brain, you splattered it on the ground and you took all of my neurons and you lined them up leg to leg to leg, you could make a chain that's long enough to reach the moon. And all of that is crammed inside of the human skull, right? And this is true not because I'm brilliant, right, but because I'm human. And so it's true for all of us. Do we have 100 billion of these cells that are making 1 quadrillion connections, and if you line them all up leg to leg to leg, you can wrap around the earth multiple times. Now, the way that they talk to each other is like this. One neuron here has a bit of information. And it wants to take this information and send it through that chain of connections. So in this space right here, where the legs just almost touch, it spits that information, and now this leg has it. This neuron has it. And that spit is everything. That spit is where all of the magic happens. That spit is what we call a thought, and it's what we call a feeling, and it's everything that we sense from our 5 senses. So think about it like this, folks. Take this ride with me. If you turn on your video today and I seeped through your screen and I was able to take away your thoughts and take away your feelings and take away your five senses, at that point, what of you is left? I mean, there's nothing about a sense of identity or a sense of self or a sense of humanity at all that could remain. At that point, it might kind of be like being in a coma. So if this spit is your thoughts and your feelings and your five senses, it also means that this spit is reality. This spit is how you sense the world around you and how you know your place in that world. The spit is every experience you've ever had. It's every memory that you can recall. And there are things that you can do every day to mess with this, your sense of reality, in a way that your brain loves. Right? So for example, if after this video you go and cuddle with a fluffy puppy, dude, that is living, right? And in a moment like that, the stresses of being a person and the stresses of maintaining relationships and trying to navigate your way through this world, they don't really show up in a moment like that. And this is different. It's a little more soft. Or if you go indoor skydiving, right? This is different in that moment. Or if you're a person that loves going on hikes and you go on a hike and you're just completely tripping out because the trees around me are all just so gorgeous. There are things that you can do every day to mess with this in a way your brain loves. And those things are good and great, but not exactly why we're together today. We are together today to learn about how drugs work inside of this process. So, if we zoom in on the space where the spit happens, what we see is that the end of one leg has a head on it, the end of another leg has a head on it. And here we have factories. And these factories are full of workers. And these factories and these workers, they spend all day and all night, all of their energy and all of their resources building all of the happy, feel-good, trippy brain chemicals that you need so desperately every day. So, who can name any of those happy, feel-good, trippy brain chemicals? Right, so we have dopamine. Most people know of this one. We also have serotonin, endorphins, GABA. There's also this stuff called PEA and acetylcholine and this stuff called cortisol. And there's a whole bunch of these happy, feel-good, trippy brain chemicals, and we're not going to talk about all of them today. We're going to talk about one that's called GABA. GABA is the brain chemical that helps regulate anxiety and memory. We can think of GABA as the brain's natural anti-anxiety medication. So, who here has learned something about anxiety before? Anxiety's hard. Anxiety sucks. I'm going to ask you to please, for the next 10 minutes, forget what you've learned about anxiety and let's think of it differently. Let's think of it first as inhibition. So inhibition can be that little voice inside of us that might stop us from doing something potentially dangerous. And that voice is different for everyone. It's a really personal sounding voice. But it might sound something kind of like, not right now. And not with those people. And maybe you should run. And you're going to get caught. And it may stop us from doing something potentially dangerous. It's a necessary survival voice that lives inside of us. Now, if that voice gets too loud and it stops us from doing some things that maybe we should do, that's when we call it anxiety. And if it happens for a long period of time, it could be an anxiety disorder. But that necessary survival function that lives underneath anxiety, it's called inhibition. This person's brain notices a natural piece of anxiety of being a person. Let's say that it's this person's first day at a new school, and it's lunchtime. And this person's walking through the lunchroom and they have their tray of food, and that voice of anxiety is being mean to them. And it's saying things like, everybody's staring at you. Nobody here likes you. You don't have any friends here. You should run. The voice of anxiety is being mean to that person. But since the brain is so kind to us, now you won't hear me say that the mind is kind to us, but the brain definitely is. The brain notices this piece of anxiety, and so the GABA workers in their GABA factories, they shoot their pieces of GABA across the gap. And when they do, it plugs in perfectly to the GABA-shaped keyholes on the other side, and it goes billions of times down that chain, and now this person has a chance to take a deep breath. And they have found a gentle piece of relief from that anxiety, thanks to the beautiful GABA in their precious brain. And that is the happy, healthy brain. And that's how most people's brains work most of the time. Hopefully, right? And again, all of that stuff is good and great, but it's not exactly why we are together today. We are together today to try to learn about how drugs work inside of this process. So, in the human body, we have two main lines of defense. And the first line of defense is our immune system. And we know this thing. The immune system fights. And it fights and fights and fights. And it fights all day and all night. It fights anything for any reason. It fights off virus and infection and illness and bacteria. And our immune system is cocky. It is a whole lot more confident than it deserves to be. Because our immune system often will pick fights that it's destined to lose. And if our immune system loses a fight, we barf, or we get diarrhea, or it's really scary and we get like Zika or Ebola, or very commonly we get a cold or a flu. And so we know that this immune system is not a perfect protector. And our brain, our precious brain, cannot afford to put all of its trust into our immune system. If our brain put all of its trust into our immune system, we could easily just get a paper cut and get bacteria in the paper cut. And it flows through our blood and it gets to our brain and we get a brain infection and we would never survive infancy if our brain put all of its trust into our immune system. So our brain has another layer of protection. All right, so who here watches Star Wars? All right, so if I shoot a laser at a ship and that laser pew, bounces off of that ship, it's because that ship has what? A force field, right? Our brain has a force field also. And in our brain, it's called the blood-brain barrier. But that doesn't really matter because we call it the big, beautiful bouncer. And we call it the big, beautiful bouncer because just like one of those big old ripped, jacked dudes in front of the hottest nightclub in Denver, that bouncer has a list. And if you're not on the list, you don't get in today. That's just how it goes. But if your name is on that list, the bouncer will move that velvet rope and he'll welcome you in and you have a great night at the club. This bouncer here also has a list. And the only things on this bouncer's list are the happy, feel-good, trippy brain chemicals that you were born with. And that's it. Nothing else gets into the brain. But wait a minute, dude. That kind of sounds like junk, doesn't it? Because we know that if somebody takes a few shots of tequila and they get loose and sloppy, that there's booze on the brain. And we also know that tequila is not one of the neurotransmitters you were born with. So it has to do something to get there, right? So very similarly, if a person is not 21 yet, and they need to fool that bouncer into letting them into the club, there's a few things that person can do. Right? A fake ID? Sure, yes, that would help, but they also have to dress the part. They can't show up in a Pokemon t-shirt and flip-flops and expect to get into the club, right? Maybe they need some big old heels or like getting their hair did or full on like war paint makeup, right? Or maybe they need a three-piece suit and a painted-on beard, and if the disguise is good enough to fool the bouncer will move that velvet rope, he'll welcome them in, and they have a great night at the club. That's what's going on here. So, if a person takes a drink of alcohol, and the alcohol gets into the stomach, and it gets into the blood, and it approaches the blood-brain barrier, the big, beautiful bouncer, the bouncer looks at that alcohol and is like, whoa, dude, you're looking awfully rough today, but obviously it's you, GABA. I'm glad to see you. Come on in. Welcome home. He moves the velvet rope and welcomes the alcohol in, dressed up as GABA. If we look at alcohol and GABA under a microscope, they look nearly identical. And close enough that it fools the bouncer into believing it's supposed to be there. So that's how any drug has a chance to get into the brain. It fools the bouncer by dressing up as one of the happy, feel-good, tribute brain chemicals that you were born with. Now, what happens next? Because I'm a classy gentleman, I like to describe this part as explosive diarrhea or projectile vomit, right? It floods this gap. It floods it with so much more fake GABA than your brain can make, more than your brain can need, more than your brain can use. It's flooded with this fake GABA. And of course, the fake GABA is plugging in to the GABA-shaped keyholes on the other side. It's going billions of times down the chain, and now this person is having a GABA-like experience. They're drunk. Their anxiety is quelched. They're disinhibited. And their memory might have some difficulties processing short to long-term memory. We often see people that are getting really drunk having a hard time remembering what they did the night before. We know that GABA regulates anxiety and memory. And it works inside of the brain cell in nearly the same way as alcohol. But here's how they're a bit different. Let's say that you are a GABA worker in a GABA factory, and you spend all day and all night, all of your energy and all of your resources building the beautiful GABA for this precious brain. And you look out the window of your factory, and what you see is that the street is flooded with your product in abundance, for free. So much more than your factory could ever make. As a GABA worker, what would you do? Yeah, screw this job. Why would I spend all of my energy and all of my resources building this stuff that's in the streets for free? More than my factory could make. These workers, they quit. They say, screw this job. I'm going back home to Canada. What happens to a factory with no workers? It runs the risk of shutting down. And if these factories are shutting down, it means that this person is not making enough or not making any new, real, fresh GABA. But for this person right now, that's not really a problem. And it's not really a problem because they have this flood of fake GABA. And then 6 or 8 or 12 or 24 hours later, when this person's not drinking and the fake GABA is gone and the real GABA is gone, the natural anxiety of being a person is going unchecked. It's going untreated. Has anyone here ever met an alcoholic who is trying to give up alcohol in their first 1 or 2 or 3 months of early recovery? Ask yourself quickly, how would you describe the emotional status of that person? I'm guessing that your answer is, this person's agitated, that they're having difficulties with memory, maybe they're shaky, they're angry, they're super disgruntled. And all of these things are aiming right at the problem here. If this person's not getting real and not getting fake GABA, the natural anxiety of being a person is going unchecked, going untreated. And unchecked anxiety has a chance to turn into many things. Anger and frustration and confusion and despair and seeking isolation. And this person's having a very real hard time. This person is major cranky pants. largely due to what they've put in their body. There's a process that happens here with these factories shutting down. There's a term for this. And if we're talking about alcohol, the term for the factories shutting down starts with the letter H. They made 3 movies about this. With alcohol, we can call it a hangover. With some other drugs, we could call it dope sick. But with all drugs, this process is called withdrawal. Withdrawal can do a lot of things inside of the body, but inside of the brain cell, it's our factories shutting down. So there's something else happening on the other side here, where the keyholes are. Right, so I live in Colorado, where it snows. It recently did snow, and it's going to snow again soon. Winter is coming. Now, the day that it snows, when it's all white and fluffy outside, the day that it snows, is it easy or is it difficult to go take a shovel to the white fluffy snow? I mean, it's work, but it's fairly easy, right? And then the sun comes up and it melts a little bit and the moon comes up and that slush turns to ice. Now, how hard is it to shovel that ice? It's super hard, right? There has been this flood of fake GABA, more than the brain can make, more than the brain can need, more than the brain can use. And not all of it does get used, and it helps form kind of like a layer of ice on the receptors, or on the keyholes here. And if this happens, let's say the factories are up and running. The factories are all up and running. This person notices a natural piece of anxiety of being a person on a Monday. And on that Monday, the GABA workers in their GABA factories, they shoot the pieces of GABA across the gap, and when they do, it just bounces right off. Because real GABA can't break through that layer of ice. And so on Monday, the natural anxiety of being a person is going unchecked and going untreated. So on Tuesday, it's a little more loud, and on Wednesday, it's really loud, and on Thursday, it's overwhelming, and on Friday, this person makes a decision to treat that anxiety in the quickest and easiest way that they know how. This person makes a decision to have 2 drinks. And they follow the decision with action. They drink 2 drinks. Their first drink, all that does is just bounce right off, just like the real GABA, right? But their second drink, that one, bounces off too. Darn it! What do they do next? Drinks number 1 and 2 didn't bring the effect that I was looking for. Maybe it's drink number 3 or drink number 4 that can start breaking through the layers of ice so that drink number 5 or drink number 6 can bring the effect that I was looking for. This person is now having to use more and more to reach the same effect as before. What is the term for that? Tolerance. This person is now having to use more and more to reach the same effect as before. There are 3 things here that are important to remember. And in these 3 ways, all drugs are similar. All drugs share these 3 traits. 1, to get into the brain, it has to dress up as one of the natural neurotransmitters that you were born with. Once it gets in and it floods the gap, we run the risk of our factories shutting down, which is the risk of withdrawal. We also run the risk of ice on our receptors, which is the risk of tolerance. These are the 3 ways in which all drugs are similar. So, before we wrap up, let's really quickly take a look at these 2 things as if they're showing up in the same person at the same time. Tolerance says, I now have to use more and more to reach the same effect as before. Withdrawal says, if I go a brief period of time without using, I face these difficult and emotional and problematic and painful kind of side effects. And we all know the quickest and the easiest way to chase those away. Use again. So this person is experiencing some withdrawal symptoms and they use again. And now that they're using again, they're also developing a tolerance, which means they now have to use more. And now that they're using more, it means that their withdrawal symptoms are getting heavier, more problematic, and more painful and more emotional. And chase those away, they have to use more of more because their tolerance is developing a tolerance. And now that they're using more of more, it means that their withdrawal symptoms are getting heavier, more problematic, more painful, and more emotional. This person's having to spend more money, more time, and more risk, and has something in their pockets. Their tolerance is increasing, which means that their withdrawal symptoms. When these two things are showing up in the same person at the same time, that's someone that we can be concerned about. That's someone that we might be scared for. What do you think the term is for this cycle? There are a few different terms that fit here. Addiction or alcoholism or chemical dependency or a substance use disorder. And while those terms mean something gently different, they're just all characterized by tolerance and withdrawal feeding each other. They're characterized by the snake eating its own tail. All right. So, I want to thank you for taking this ride with me. I want you to know what's coming next also. What we have coming next is, instead of the three ways in which all drugs are similar, it's how is this kind of drug different from that kind of drug? The answer to it is fairly simple, and it's just, what costume does it put on? We already know that alcohol dresses up as GABA. Let's find out what other drugs dress up as. Thank you, folks.